just like you can graph linear inequalities, you can graph absolute value inequalities. So we're going to review graphing linear inequalities and absolute value inequalities. So a solid boundary line, when you're graphing, is a solid line, and you're going to use a solid boundary line if you have less than or equal to or greater than or equal to. A dashed boundary line is just a line that's dashed, and this in a less than or greater than means that you're not including that boundary line. So if you're graphing an inequality and your line looks like this, then a point that's on the line would be included in your solution if it's a solid boundary line, but a point that's on the line on a dashed boundary line would not be included. So to graph an inequality, what you want to do first is solve for y. So in this case, y is already solved. So this is in slope-intercept form. So the slope is 1 and the y-intercept is 8. So I'm going to go up on the y-axis. I'm going to go up 8 units, 1, 2, 3, 4, 5, 6, 7, 8, and make a point for my y-intercept. And my slope is 1, so I'm going to go up 1, right 1. And then it is going to be a dashed line, or dashed boundary line. So I'm going to make a dashed line. And the last thing you have to do is figure out where you're going to shade it. So you can either shade on this side of the line or on this side of the line. Now, because this is less than, I'm going to shade underneath the line. So to figure out what's underneath is what I do is I picture somebody having to climb up the ladder. So if you climbed up a ladder, you would fall off the ladder if you climbed up on this side. So you're going to climb up on this side. So a less than symbol, such as this, means you need to shade underneath the ladder. And if it was greater than, you'd shade above the ladder. But this is less than. Okay, second one. Y is greater than or equal to negative 5x. So again, your slope is going to be negative 5, and your y-intercept is 0. So I'm going to start at 0 and go down 5, right 1, down 5, right 1. And it's going to be a solid line. It's solid because it's greater than or equal to. So I connect these. Oops, I can already see a little bit that I went over too far right here. So greater than is, picture somebody climbing up the ladder. If you were on this side of the ladder, you would fall off. You'd have to be on this side of the ladder. So I make somebody on this side of the ladder, walking up the ladder. And greater than means that you're going to shade above their head, okay, on the same side as their head, so this side. So that's going to be greater than. Now, so my greater than, less than ladder part works. Another way you can do it, which other people teach it, is pick a test point. So a test point could be any ordered pair. I usually don't include 0, 0. I don't include 0, 0 if the line is going through 0, 0. So I'm just going to I'll make 1, 1 as my test point. So the ordered pair 1, 1, when I plug this 1 in for x and this for y, I'll get 1 is greater than or equal to negative 5 times 1. So I'm plugging it back in here. So is 1 greater than or equal to negative 5? Yes, it is. So that's why you're shading on the same side as the test point. Okay, graph each inequality. So this time we have an absolute value. So you can tell with this absolute value that it shifted left 2 and down 3. So the vertex is going to be at left 2, down 3. So I'm going to go left 2, down 3. And then it's opening down. The slope is negative 1. So it's going to go left 1, down 1, right 1, down 1. And it's going to be a dashed line. So this is my dashed line. Now to shade for inequalities on an absolute value, you have two ladders, but I'm just going to make it simpler. This is called the vertex. So if it's greater than, you're going to shade the area above the vertex. So here's the vertex. If you're shading above the vertex, it also includes this outside part. So if it's less than, you would shade underneath the vertex. Okay, example 2, I'm going to find the vertex first. So the vertex is at 5, negative, or 5, 2. So I'm going to go over 5, up 2. And my slope in front, again, is a negative, so I go down 1, right 1, down 1, left 1, down 1, right 1. This is going to be a solid boundary line. Okay, it's solid because it's a less than or equal to or greater than or equal to. And it's less than, so I'm going to shade underneath the vertex, which is right here. So this went infinitely both ways, shade underneath.